So there is my YouTube channel like Electronics and Ease. Please do like, share, and subscribe, everyone. Okay. Now we will be starting the demo session from microwave and antenna. So microwave and antenna, as you know, this is a 6M subject, and many people have backlog in this subject because of lack of practice of problems and what kind of questions they are asking. So we will be learning that in detailed way in the crash course. Okay, students, like this is a demo video, like interested can join. So first we will be learning the important questions. Like this is module 1. Module 1, the topic 1 is a microwave system. Okay, this question they are asking in the question exam for 6 marks, because the subject is only microwave theory and antenna, right? So they will be asking you a microwave system to explain. So how you have to start, if they have asked like how the question they will ask is briefly explain about the microwave system, or else write about microwave system. So like this they are asking the question in your exam. So how will you write? So a microwave system start with like this. Okay, a microwave system consists of a transmitter subsystem. Okay, a microwave system consists of a transmitter subsystem. It will be including a microwave oscillator, waveguide, a transmitting antenna, a receiver subsystem that includes a receiving antenna, a transmission line or a waveguide, a microwave amplifier, and a receiver. Like we will be learning all this in our 5 modules, like what is a waveguide, what is a transmitting antenna, and all. So these are the components of a microwave system. What and all it contains? It consists of transmitter subsystem, and it consists transmitter subsystem consists of a microwave oscillator, and it will be having a waveguide. So like this you have to write waveguide, a transmitting antenna. What does a transmitting antenna does? It will transmit the wave signals to the receiving antenna. So, and it will be having a receiving antenna, or transmission line, or a waveguide, or a microwave amplifier. So you write it in points like transmitter subsystem, microwave oscillator, waveguide, transmitting antenna, receiver subsystem. So this you write in points. If this question they ask in the examination. Okay, like we will be providing 10 to 11 questions from each module. So if you study that, it's more than sufficient. No need to go to, like we will even provide handwritten notes and all. Next you have to draw this diagram uh, for microwave system. So I told you like what and all it consist. It will be having so this diagram you have to draw, students. Like I told, it will be having a transmitting antenna. This will be the receiving antenna. So transmitting antenna is towards the left side, receiving antenna is towards the right side, and you will be having two stands in the receiving side and one stand in the uh, transmitting side. Draw neatly this diagram. Okay, microwave source, you have to show microwave source, wave meter, calibrated attenuator, transmitting horn antenna. So antennas, there are more types. Like we will be learning that in 5th module, I guess. So there are many antennas like Yagi Udda, omnidirectional. So that question also is important from the 5th module. So transmitting horn antenna and a receiving horn antenna. And I told it will be consisting an oscillator also. This is an oscillator. So, and this is a waveguide, waveguide termination. So this diagram you have to write for the microwave system. If they ask, this is your first topic in your like gun diode is also important. So this is microwave system, like how the microwave system looks. So this diagram and those components you have to write, and along with the explanation, whatever they have given, at least 3 to 4 lines you write explanation, so that you will be getting complete 6 marks, whatever they have allocated for it. Okay, this is not such important, that transfer electronic devices. So we will be focusing on the important topics only. Okay, the next important topic, like for 10 marks, they are asking students, what is a gun diode? Like briefly explain about the gun diode, or else they can ask you write about gun diodes, or they will be asking you to write about gallium arsenide diodes. Okay, so gallium is a 13th group element. Arsenic is a 15th group element. So, like P type semiconductor and N type semiconductor, like both merged together, that is the gun diode. Okay. How to start explaining it? Because it is a 10 marks, you are not supposed to uh, write however you want. Okay. You have to start from the initial part, introduction part, you have to start. In the introduction part is very much important. Gun diode is very much important for 10 marks. So, how to start? Gun effect diodes are named after JB Gun. This and all, years and all, if you remember, you can write 1930. Discovered a periodic fluctuation. This point is very much important, students. You have to write a periodic fluctuation of current passing through the N-type gallium arsenide specimen when the applied voltage exceeded a critical value. This definition you have to write. So like this only you have to write, because this is mentioned in the textbook. Okay. Gun discovered gun effect in the year 1930, a periodic fluctuation of current passing through a N-type gallium arsenide. So let us assume this is a gallium arsenide specimen. Whenever there exists a periodic fluctuation of the electric a periodic fluctuation of current passing through the N-type gallium arsenide specimen when the applied voltage exceeded the certain critical value. Don't buy it, like understand. So whenever a current was passed through this gallium arsenide, what happened? Uh, in that specimen, the applied voltage exceeded some critical value. So the applied voltage exceeded some critical value that led to a diode discovery. This first you have to write this definition in the year 1930, and you have to write N-type gallium arsenide only. Okay. Okay. Now, gun effect. Students, is very important. A screen like gun effect happened only for the N-type gallium arsenide diode. So what happened? In that there was a periodic fluctuation of electric current in an N-type of semiconductor, and because of some critical value that you have to write, and you have to start writing this. Okay. A schematic diagram of uniform N-type gallium arsenide diode with ohmic contact is shown in the figure. You have to write this figure, like you have to draw this. Diagram carries 3 marks or 2 marks. Diagram carries 2 marks or 3 marks. Okay. So this diagram you have to show, like draw, use a scale, proper scale. Like use pen only for diagrams. Don't use pencils for diagram, like because it won't scan. You won't get marks for the diagram. Like whenever you draw any diagram or a circuit, use black color dark pen. Don't use pencils. Many do that mistake, that will not be scanned properly. So, and there are high chances that you lose marks for the diagram. Okay. So you have to draw this diagram. You have to show cathode, anode. See, cathode is usually quoted in the cathode is usually coated, and like the distances you have to write 120 micrometer. Micro means 10 to the power of minus 6. Okay. So this diagram you are supposed to write like how what three-dimensional I am showing, like how it is doing going metal contact, metal coated contact, high field domain, and this will be the cathode, and this will be the anode. Anode is usually positive. Okay. This is how you have to first you have to write the definition, whatever I told. The second, what you have to do, you have to write this diagram. Step, first step is you have to write the definition. Like what is the definition? Gunn observed in the year 1930 that whenever a current is passing through an N-type gallium arsenide diode, what happened? The like there was a fluctuation above the critical value. First, you have to write the definition. Later, you have to start writing the diagram. So, step by step, they will be giving 10 marks. Okay. 10 marks is very important. All the question paper, they are asking this question, students. So, microwave system, we learned. Gun effect is another second important question. You have to write. Like this only, we will be going all the 5 modules, but you have to follow, write, and practice the days whichever we teach in the class. Okay. So next, what you have to do? So you have to write the gun effect diagram. Okay. This subject is vast actually. There are more concepts, more problems, but we will be doing the fixed questions, whatever they ask in the exam. Like I will be telling, this is very important. See this gun effect, 10 marks they will be asking. So next you have to write the theory related to it. Okay, after drawing the diagram, above some critical voltage corresponding to an electric field, this values and all you have to remember, write and practice. So 2000 to 4000 volts per centimeter, the current in the every specimen became a fluctuating function of time. Okay. Above some critical voltage corresponding to an electric field of 2000 to 4000 volts per centimeter, the current in every specimen, whatever the specimen you considered, it became a fluctuating function of time. So next what you have to write, this is your first point after writing the diagram. In the gallium arsenide specimen, this fluctuation took form of a periodic oscillation superimposed upon the pulse current. So, see, like in background, temple is there. The like because of that disturbance, I feel everyone are able to hear. 5 minutes it will go off. Okay, in the gallium arsenide specimen, this fluctuation took form of a periodic oscillation superimposed upon the pulse current. So, what in gallium arsenide specimen, what happens? The fluctuation took form of a periodic oscillation superimposed upon the pulse current. The frequency of oscillation was determined mainly by the specimen and not by the external circuit. Same theory of to write. Don't write own theory, like whatever, like you can even write this theory like cathode. This you can introduce students like cathode, anode, and what's the dimensions you can even write initially, and later you can go. But this points whatever I have written or whatever there here, this you are supposed to write for sure, otherwise you won't get marks. Okay. The frequency of oscillation was determined mainly by the specimen and not by the external circuit. You can underline this, like this values and all. If you write, you have to underline and show so that the invigilator gets happy that you know everything and will give the complete marks out of 10. You might think, oh, I have written gun effect. by own. But these words and all, if you have not used, you won't get full 10 on 10. Okay. Just diagram and own theory and all, if you write, like you will get just 2 or 3 marks. See, like don't miss with such easy questions. Okay. Okay. You can study whatever I have taught, whatever the definitions I have thought. That's the major mistake. Like what you will do, mostly all the students, what they will do, they will just learn the diagram of gun effect and learn the graphs and write theory, whatever comes to your mind. That doesn't happen. Theory they will read. Okay. Your friends might tell, okay, only if they see only some invigilators, but not all invigilators. But why to take risk? Right? Whatever the theory they have mentioned in the textbook. Okay. The frequency of oscillation was determined mainly by the specimen and not by the external circuit. The period of oscillation was usually inversely proportional to the specimen length, very important, and closely equal to the transit time of electrons between the electrodes, calculated from their estimated velocity of slightly over 10 to the power of 7 meter per second. So first you have to write about the electric field one and what happens whenever the periodic fluctuation takes place. See next what happens. The third point is the frequency of oscillation was determined mainly by the specimen and not by the external circuit. Okay. Next, what's the next point? The period of oscillation was usually inversely proportional to the specimen length and approximately equivalent to the transient time. Transient time, you write like don't write any definition, like Ti I can take. Okay. Of the electrons between the electrodes, calculated with the estimated velocity over 10 to the power of 7 meters per second. These values you have to remember. Like what this they have mentioned in the textbook. Same thing, because Gunn discovered it. You can't change the values, whatever he did the calculation. Okay. The peak pulse microwave power by the gallium arsenide specimen to a matched load was measured. Value at zero point 0.5 volt at 1 GC per second and zero point 0.1 watt at, this is gigacyclic per second we will call, were found, corresponding to 1.2% of pulse input power. See, it was 0.5 volts at 1 gigacyclic per second and 0.15 volt at 1 giga were found, corresponding to one, like whenever you gave only 1 to 2% of input power only, this was observed. Okay. From Gunn's observation, the carrier drift velocity is linearly increased. So what did the gun observed was the carrier drift velocity is linearly increased from 0 to maximum whenever the electric field is varied from 0 to a threshold value. So this is your next point, what you are supposed to write. Like point wise only I have mentioned in the notes. So same thing you have to follow. Like at least write and practice. If you are not able to remember the values, please do write and practice, because it's 10 mark important. So it's important that you write and practice so that you get complete marks. So like this, if you write, no invigilator will cut even a single mark. Okay. When the electric field is beyond the threshold value of 3000 volts per centimeter for the n-type gallium arsenide, the drift velocity is decreased and the diode exhibits negative resistance. So what happens whenever the electric field is beyond the threshold value? Threshold value andre enu? It's a kind of minimum value, whatever the required for that, so that there will be a linear proportion. Beyond that, you are extending, means what happens? The drift velocity will decrease. So that I will be showing in the graph. So I told the drift velocity increased whenever the voltage was applied in the range of 2000 to 3000. Whenever it was linear, it was, and what happened, exponentially increased whenever it was from 2000 to 3000. Later on, what happens, the diode exhibits the negative resistance, so it started to decrease. So what happened, it started to decrease. That the gun observed in his experiment. Okay, so this graph you are supposed to draw. The theory, after theory, you have to supposed to, first step you have to write gun effect definition. Next you have to draw the gun effect diagram. Later on, explain this whatever the points I've explained. Next step is to write the graph. This is how you have to follow the method, students. Don't write your own way, like first diagram, graph, like that. Don't do. Step by step definition, diagram, theory related to it. Next, plot the graph related to it. So like this, you will be getting full marks. Like this only you have to do. Okay, in graph, what is x-axis? Drift velocity is usually measured in centimeter per second, and field, electric field is usually measured in kilovolts per centimeter. So this is centimeter per second. This unit also you are supposed to write correctly. Remember. Next, there are two graphs related to it that you have to show. First graph you are writing for gun effect. The current fluctuations are shown. The current waveform was produced by applying a voltage pulse of 16 volts. So voltage you are applying, this is a current waveform, 16 volts you are applying for 10 nanoseconds duration for an n-type gallium arsenide, which is 2.5 into 10 to the power of minus 3 centimeters. So see, so many values are there in this question which you have to remember. Okay, this values only you have to write. Don't write own values. Okay, so first graph you should write, and you have to write what was the voltage? First voltage is 16 volts. Time duration is to 10 nanosecond duration. And what is the length of the gallium arsenide? 2.5 into 10 to the power of minus 3 centimeter. So microwaves usually operate in gigahertz. So frequency you have to, it will be always in gigahertz. So this you have to show the graph, write the values and plot it. Like this you have to plot for the first graph. Next, you have to go with the second graph. Okay. Next, you have to show this graph. Draw this graph. Okay. How the lower trace had 2 nanosecond in horizontal axis and zero point 0.3 ampere per centimeter in the vertical axis. The upper trace was the expanded view of the lower trace. So whenever we expand the upper trace of the lower trace, we will be getting the upper trace. Avage ಹೆಂಗ್ ಕಾಣಿಸುತ್ತೆ? The graph looks like this. Draw like this. Gunn founded that the period of these oscillations was equal to transient time of the electrons to the specimen calculated from the threshold effect. This is how you have to explain Gunn effect. Still there is there. You have to show calculations also. Wait 1 minute. Gunn also discovered that the threshold electric voltage varied with the length and the type of the material. Okay. So Gunn also observed, after drawing the second graph, you have to explain this. Gunn also discovered that the threshold electric field, ETH, so I will be varied with the length and the type of the material. He developed an elaborative capacitive probe for plotting the electric field within an n-type gallium arsenide of length 210 micrometer and cross-sectional area 3.5 into 10 to the power of minus 3 centimeter the whole square. Like if you are able to remember all the values correctly, do attempt this question. or else go with the other question. Like if you have Smith chart, if they are asking Smith chart, if you know how to plot Smith chart, or else the transmission line equation. So if you can remember this question, values all correctly, calculation substitution, then attempt this question. See, don't miss this such a easy question. ಇದ್ ಜೊತೆಗೆ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಲೈನ್ ಈಕ್ವೇಶನ್ ಅಂದರ್ 10 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ಬಿಟ್ರೆ ಏನ್ ಮಾಡ್ತೀರಿ? 20 ಈಸಿಗೆ ಬಂತಲ್ಲ, ಇನ್ ಬೇರೆದೆಲ್ಲ ಏನು ಓದೋದ್ ಬೇಡ ಅಲ್ಲ. ಹಾ, ಸೊ ಥಿಂಕ್, ದಿಸ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್. Gun effect, this values and all you have to remember. So first step is write the definition of gun effect. Later what you have to do, you have to write the theory related to it, draw the diagram, write the theory related to it, and plot the first graph. And first graph, what and all the values are there, you explain. The theory, whatever written here, this 5 pages, you have to write completely. 2 pages you have to write the theory. Like don't see what you think. If you draw a diagram and graphs, they will give a full marks. Not like that. You have to do, like we have revaluation papers with us. They have not given the marks because 10 marks they have to give means you have to write everything correctly related to it. Okay. You have to calculate this. You will be getting this. Okay. Okay. After gun effect, the next important concepts which will appear are, so see how many concepts are there in this module one only. Uh, so you will be learning introduction. So next, transmission line and solution. So transmission line equations, very important, 10 marks again. Solution of transmission line equation, reflection coefficient and transmission coefficient, again very important. It's denoted like this. Reflection coefficient, transmission coefficient, SWR, Smith chart, very important. Impedance matching and impedance using single stub. Don't go double stub. Okay. That's not in your syllabus. You might have done in your labs, but it's not there in your syllabus. So after gun effect, you have to study this much, students. See how many concepts are there. Like you have to prepare correctly. We will cover all the topics. Don't worry. See how they are asking the question. Transmission line equation. So transmission line equation, BTU questions on transmission line equations, how they are asking? They are asking by considering the elementary section of transmission line, derive the transmission line equation. If they give this question, you have to write like, you have to derive whatever I am teaching now. Starting from the fundamentals, derive the expression for the voltage and current at any point on the transmission line. That is also 10 marks. Derive the transmission line equations by a method of distribution circuit theory. Any question, like whatever they ask, the same answer you are supposed to write. Okay, how to start with the transmission line equation? Okay, wait, student. Like this again, step by step. First theory, okay. Based on the uniformly distributed circuit theory, a small length of conventional two-conducted transmission line can be represented by an equivalent symmetrical T-pi network with constant parameters R, L, G, and C per unit length. Very important theory what you are supposed to write. What is R? R is resistance, L is inductor, G is conductance, and C is conductivity per unit length. Okay. As consider a small length delta Z of a transmission line, assuming the sinusoidal variation, the instantaneous line voltage and line current. So we are assuming that the transmission line equations follow the sine wave convention, and for that, what happens? what will be the voltage and the current, instantaneous line voltage and instantaneous current. That expression we will be denoting using this v of z comma t. It is equivalent to v of z into e to the power of j omega t. E to the power of j omega t is, this is a real part and this is a complex part. Okay, this you have to remember. This two equations you are supposed to write initially. So this you will be explaining, like 3 points you have to write, and this equation, this carries 1 mark. If you write this, you will be getting 1 mark. Okay, are you able to follow till here? You have any doubts? Hello, Dikshita, R, Tilak, and all. Anyone having doubts till here?
No, no,
Okay.
no, sir.
See, if you join for batch one, you will be having more time. We can do complete syllabus and go, like batch two will be on the faster track. So that uh it's not, I will not insist that to join. You already know how much marks you have got. Like, don't waste money for the revaluation part and all. Like, if you have less than 10, it's high, there are high chances in revaluation also they won't pass you. Less than 10, less than 15, 14 and all. So it's your, up to your wish, like how you take. Okay. This diagram you are supposed to draw. How the transmission line will look. It will be having a resistor, inductor, and a conductance and capacitor. So this diagram you have to write and practice, like generator, like three. It will be having three meshes. Okay. Uh, Same. This is diagram is mentioned in textbooks. Many people are doing another diagram, or like this is your standard textbook diagram. Okay. You're supposed to draw this diagram only. Okay. It will be having a generator. It will be having a load. It will be having an resistor, two resistors, two inductors. So to see, like resistor only is used for both conductance and this resistivity and conductance, G conductance. Okay. So this symbol you have to show, and you have, for that you have distinguished using G delta Z, and because it's a small element we are taking as delta Z. Whenever it is a small element, you have to consider as delta. Okay. Like this you have to start the derivation. Okay. Using case KVL, Kirchhoff's voltage law, the summation of voltage drops around the central loop. You have to apply KVL for the loop. Okay. How to apply KVL? Kirchhoff's voltage law. What does the Kirchhoff's voltage law states that? So you have to add whatever the components are there. So first component, what is there? Here it is. 1 minute, I will use this highlighter. Like, later rejoin the same meeting, we will continue that derivation. This derivation I'll finish and I will stop. Like, this will be worth for the demo. So using Kirchhoff's voltage law, the summation of the voltage drops around the central loop given by V Z of t is equal to current I Z of t. This, okay, into R delta Z plus L delta Z into, see, inductor always you have to use differentiation. Whenever you used Laplace transforms, you would have learnt. So it's partial differentiation of dou I by dou t into Z of t plus voltage. This voltage, whatever it's there, like Z plus delta Z comma t. Since it's a two dimension, it will be having two dimensional variables also, students. Okay, first you will be writing the Kirchhoff's voltage law equation. Next, what you will be doing, V of Z, t is I Z of t plus L delta Z into dou I plus V Z plus you v next equation. Wait, time is going. B z of t is equal to I or I comma I of z comma t r delta z plus L delta z into dou I by dou t into z of t. So this is in the summation. I will be using the differentiation rule and I will be expanding it because two are there in the bracket. So that expansion I will be doing v of z comma t plus dou v because it's partial. I will be using dou v by dou z into z of t into delta z. See, again, join the same meeting link, okay? Like we will continue from this step, okay? Because I can't continue further time.